My name is Peter Decker, and I'm presenting my project, Lunar Lander Reinforcement Learning. Intelligent agents have been rapidly entering our daily lives, from a jet's autopilot to luxury self-driving cars. Simulated environments are crucial for testing advanced software before it becomes mainstream. The advanced physics of the Unreal gaming engine has been used to train self-driving cars. Lockheed Martin tests missile designs and guidance software extensively prior to manufacturing and testing a physical product. Simulated environments allow companies to ensure improved safety, reliability, flexibility of their product, and most importantly, it can reduce costs. The objective of the project was to create a program that would autonomously land a space exploration device on a planetary object. The planetary object was the software-generated environment provided by AI Jim's Lunar Lander. The lander's goal is to safely land on the landing pad. Each episode begins with the lander falling towards the ground and ends when it safely lands on the landing pad or crash lands. Its goal is to land right in between the two flags. Using reinforcement learning, an intelligent agent was trained to control the lander. The lander has 4 actions it may select to assist with landing. These actions are known as states. The first state is to do nothing. The second state is to use the left engine. The third state is to use the main engine, and the final state is to use the right engine. To facilitate learning, a reward and punishment system was implemented. The lander was rewarded when it moved towards the landing pad, landing safely and at a slow speed on the landing pad. Solving the problem gave the lander 200 points. Landing safely gave between 100 to 140 points. If the landing legs touched the surface, it got an additional plus 10 points. However, it was also punished for mistakes. Crash landings were a reduction of 100 points. And for every frame in the video that an engine was fired, it was a reduction of 0.3 points. See, the lander was punished when it moved away from the landing pad, landed outside the landing pad, or used one of its engines. We'll look at one of the episodes of the Lunar Lander. This is episode 64, which was pretty early on in its training. It achieved an average score of -78. Let's see. Let's run the program. As you can see, one of its legs did touch the ground, but it was firing its engine for most of the time and landed on its side. I wouldn't want to be in this lander. By around episode 4000, things started to improve. Even though the score wasn't as good, the average score remained about the same. It didn't really increase or decrease that much. That means the program has been improving, although it must have learned that it needed to fire its engine in order to land. That's why I think it hasn't reached a positive score. As you can see, it did much better. It landed within the flags. One of its legs touched, but it's still not perfect. Let's see. If you would like to learn more, these are some resources I used while learning to use OpenAI, train a deep Q network, creating classes in Python. Thank you.